Now, yesterday we showed how to find the expansion of a binomial by multiplying. We used FOIL and then we used our box method. However, it does take an extensive amount of time, especially if you get much over, raising something to the power of 4. So today we're going to look at Pascal's triangle because it is a relationship that allows us to expand a binomial. However, it does not take near the amount of effort as it would take to work them out the old way. Bryce, please sit down. So we have 1. So hopefully you see the relationship. I'm not sure how many of you have seen it, but I'm going to show it to you. Someone asked me if I had to memorize this, but there's really no reason to memorize it because there's an extremely important pattern that we're trying to help you pick up on. You start with your 1, 1, 1, and then 1 plus 1 is 2, and 1, 1 plus 2 is 3, 2 plus 1 is 3, 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, 1, 1 plus 5 is 6, 5 plus 10 is 15, 20. If you understand how to do it without writing, it's good to have in your notes. 1 plus 6 is 7, 6 plus 15, 21, 15, 20 is 35, 35, 21, 7, and 1. If you were going, can I teach the lesson and then you will have questions at the end? Give me a second. You can continue this binomial expansion as far as you want. Now, yesterday we first started with x plus 2 squared. We FOILed the two together and you should have the answer in your notes. In order for you to see how the triangle works, I understand that FOILing is an easier process for some. But in order for you to understand how the triangle works, we are going to say that we are at a plus b squared. Our coefficients that we need to use for a plus b squared are 1, 2, 1. We are then going to take the first term of x and we are going to start on the left with x squared, x to the first, and x to the 0. We take the 2 and start on the right, 2 squared, 2 to the first, and 2 to the 0. Anything to the 0 power is what? 1. Anything to the 0 power is 1. So this actually has a value of 1, and this x to the 0 has a power of 1. So we end up with our x squared. 2 times 2 is 4x, and 2 squared is 4. If you look back in your notes, or you think about what your answer would be for x plus 2 times x plus 2, when you FOILed these, you got x squared plus 4x plus 4. Next example. If we want x plus 2 cubed, that means we're on this list of coefficients. So we write 1, 3, 3, 1. We start with our x on the left. Because we're cubing it, it's going to be x to the third, x to the second, x to the first, and x to the 0. What am I going to start on my right with? 2 to the third, 2 to the second, 2 to the first, and 2 to the 0. We then are going to have to clean this up. We're going to add all these terms together, but anything to the 0 power is 1. So we keep our x to the third. This is 3 times x squared times 2, so we can put the two coefficients together and get 6x squared. 2 squared is 4, so 4 times 3 is 12x. 2 to the third is not 6. 2 to the third is 8. 2 times 2 is 4 times another 2 is 8. So if you compare to your notes from yesterday, this should be the exact same answer that you got when we boxed things out. Some of you may still be stuck in the, well, I want to do it using the box method. But in reality, the whole point of this is to see if you can apply the pattern that we have found in our binomials. So, if we had x plus 2 to the 7th, and you wanted to talk about doing x plus 2 times x plus 2, and then multiplying that by x plus 2, and then multiplying that by x plus 2 over and over and over and over, you are going to have probably hundreds of places that you could make one mistake. One number off and you could make a mistake. If you want to use the binomial theorem or Pascal's triangle, I've done it in under 3 minutes in my last 2 classes. Well, I think you can see the timer right there, so I'll start it. It's better if Thomas times you. However, so we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and I want the 7th. So these are the coefficients that I am actually going to be using. So I'm going to write 1, 7, 21, 35, 35, 21, 7, and 1. If my first term is an x, and we're raising to the 7th power, then I have x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. I then have to do my 2's. So I have 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and then 2 to the 0. The 1, 2 to the 0 cancels out as 1. 1 times 1 gives me my x to the 7th. This is 2 to the 1st. Anything to the 1st power is 2 times 7 is 14x to the 6th. This is going to be 2 squared, which is 4 times 21 is 84x to the 5th. 2 to the 3rd is 8, and 8 times 35 is 280x to the 4th. 2 to the 4th is 16, and 16 times 35 is 560 x to the third. 2 to the fifth is 32 times 21 is going to give me 672x squared. 2 to the sixth is 64 times my 7, which was my coefficient, gives me 448x plus my 1 times 1 times 2 to the 7th, which is 128. Oh, how long? 2 minutes. Oh, okay. He didn't count the triangle. One way or the other, it's still pretty efficient if you're talking about doing the whole thing. Great. Then it should be easy. If you have x minus 3 to the fourth, why don't you pick up a pencil and try? You are actually going to make your triangle 1, 1, 1. If you can get started at that point, you should be able to figure it out. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So since it's to the fourth, my coefficients are going to be 1, 4, 6, 4, 1. I then have to start with my x. So I have x to the fourth, to the third, to the second, to the first, and to the 0. And in this case, do I use 3? Okay, so if you're going to use a -3, you are actually going to want to use parentheses. -3 to the third, -3 to the second, -3 to the first, and -3 to the 0. Anybody have a question about that? Yes, you can. I'll show you an example in just a second. If you have -3 to the 0, that's your 1. So my first term is going to be x to the fourth. If we have a negative raised to the power of 1, does it stay negative? Yes. So this is actually going to be -3 times 4, which is -12, x to the third. Negative times a negative makes a positive 9 times 6, which is 54x squared. A -3 raised to the third power is -27. So -108x. And then -3 to the fourth power. Anytime you have a negative raised to an even number, you're going to be left with 81. So it's positive. If you do not put parentheses around the negative, then you will get an incorrect answer. This question, I'm not sure if I'm going to finish it on the video, but if we want, this is your rock star question. The ones that I've done so far are about a level 1. If you consider yourself to be a rock star, then this is the question for you. If you have 2x plus 3y to the 9th, and I only want the fourth term, I'm going to cheat and start with my Pascal's triangle. So 1, 6, 15, 20, 15, 6, and 1. 1, 7, 21, 35, 35, 21, 7, and 1. 1, 8, 28, 56, 70, 56, 28, 8, and 1. And because we just want term 4 in the 9th power, then it is going to be 1.